Welcome to the 10th quarterly report detailing the progress made by NASA's ARES projects on America's next launch vehicle. Last quarter, the project reported on upper stage confidence panels, friction stir welding simulations, and J2X power pack disassembly. Work from last quarter continued with more wind tunnel analysis and fabrication of the first stage's process simulation articles. A 1% scale model of the ARES 1X vehicle was tested this quarter to gain high-fidelity data about the aerodynamic environment affecting the vehicle separation of the first and upper stage. The separation event is critical as it occurs at nearly 5 times the speed of sound. Wind can also affect a rocket prior to launch, so engineers are studying the effects of ground-level winds on the ARES 1X as it rolls to the launch site and while it sits on the launch pad. In addition to the work on ARES 1 and 1X vehicles, testing has begun on the aerodynamic environments affecting the ARES 5 cargo launch vehicle when it launches late next decade. Engineers tested sensors this quarter that could be used as part of the ARES 1 integrated vehicle health monitoring system. A scale model of a solid rocket booster nozzle was manufactured with intentional defects, and sensors were placed along those areas before firing. This helps engineers design an advanced warning system to alert the crew in the event of malfunctions during an actual flight. ARES tested the first stage's drogue parachute in July. The 68-foot diameter parachute was attached to a jumbo dart test vehicle that weighed 12 tons. The drogue chute is the second chute to deploy during re-entry. It provides the initial deceleration of the booster before the 3 main parachutes emerge to finish slowing the first stage prior to its landing and recovery from the Atlantic Ocean. The inert forward segment of the ARES solid rocket booster was inspected via a large X-ray machine this quarter. Large X-ray film panels are passed through the center or bore of the motor segment, while a large X-ray machine focuses beams inward through the simulated propellant. After more than a year of modifying the facility and installing new world-class friction stir welding tools, engineers at Marshall conducted the first demonstration of the robotic friction stir weld tool this quarter. In order to test the welding of complex curves, the tool fused together 2 dome panels, originally fabricated for the shuttle's external tank project. Once this testing is complete, the team will start welding ARES fuel tank domes. Using another friction stir weld tool, engineers at Marshall are creating prototype tank barrels to test the processes and procedures before instruments are installed for structural testing. A large-scale version of Marshall's robotic weld tool is now being delivered and installed at the Michoud assembly facility, where the final flight hardware for the ARES upper stage will be created. Components are now being manufactured and tested for use in the ARES 1 roll control system. Valves to control everything from hydrazine fuel to helium are being built, along with the necessary electronics to drive the system automatically or by crew input. ARES roll control requires split-second timing with high fluid pressures, so engineers at Moog have been testing new elastomers and improved control electronics to meet the project's needs. The ARES team has also been conducting assembly and handling tests for the ARES 1X test vehicle roll control system. A cold flow testing unit will be used to verify that the system will function properly during liftoff. ARES engineers tested a small solid rocket for use as an ullage settling motor. This motor will be used to settle any fuel in the upper stage tanks when the spacecraft is in orbit. Further tests are planned in the series to help finalize the ullage motor's design. Components from the J2X Power Pack tests article were recently removed from the stand at Stennis Space Center. Those components are now being disassembled and examined by the engineers to determine what effects the test sequence had on the parts. More Power Pack testing will be conducted in 2010 using developmental J2X turbo machinery. The J2X team continued testing a workhorse gas generator at Marshall this quarter. The workhorse gas generator program conducted 53 individual tests in a variety of injector configurations. In addition to their work on the upper stage, Moog is providing actuators to control several critical valves on the J2X engine. Join us again next quarter for further developments on the first stage inert test motor, J2X gas generator testing, and the fabrication of upper stage test components at Marshall. If you would like more information about ARES plans and progress, please visit us on the web at nasa.gov/ARES.